This section introduces knowledge management, KM, as a systematic approach to managing and sharing knowledge to improve decision-making, processes, and system performance. It emphasizes KM's importance for TIS managers by providing access to the right information and tools, enabling informed decisions and operational improvements. The goal is to ensure TIS managers have access to valuable data, insights, and expertise to optimize system operations and address challenges in real time. This slide discusses knowledge management for decision-making. It highlights the importance of real-time access to data from systems, maintenance logs, and performance reports for TIS managers. It introduces the use of predictive analytics to anticipate potential system issues and proactively implement solutions. The overall impact is improved decision-making, enabling TIS managers to make quicker, better decisions, improve response times, and enhance system efficiency. This slide focuses on efficient resource management and KM. It emphasizes the role of a centralized knowledge repository in storing system documentation, maintenance records, and user feedback in an accessible location. It explains how KM minimizes redundancy by learning from past projects, issues, and solutions, ensuring optimal resource utilization. It also underscores the value of collaborative tools in fostering collaboration among cross-functional teams, enhancing communication, and efficient task delegation. This slide discusses continuous improvement and KM. It explains how TIS managers can integrate feedback from system users and technical specialists to enhance performance. It highlights how KM allows managers to review past projects, identify bottlenecks, and improve workflows for future initiatives. It promotes a culture of innovation by leveraging shared knowledge to introduce new solutions and optimize transport system functionality. This slide discusses sensitivity analysis as a characteristic and capability of DSSs. It explains that sensitivity analysis examines how changes in variables affect the outcomes of a transportation model. An example illustrates how a city traffic authority uses a DSS to simulate traffic flow, analyze the impact of increased traffic volume on intersecting roads, and evaluate alternative traffic light timings or detour routes. This slide is about what-if analysis as a characteristic and capability of DSSs. It explains that what-if analysis tests different scenarios to see how changes in assumptions or input data impact decisions. An example illustrates how a public transport operator explores the impact of rising fuel prices and commuter shifts from car to train on operational costs and ticket pricing, and how the DSS recommends fare adjustments or schedule changes. This slide explains goal-seeking analysis as a characteristic and capability of DSSs. It details that goal-seeking analysis finds the input values required to achieve a desired outcome. An example illustrates how a logistics company uses DSS to determine the minimum number of delivery trucks needed to meet a 24-hour delivery goal across peninsular Malaysia, considering distance, traffic, and loading time. This section introduces Group Decision Support Systems, GDSSs. It defines a virtual group as a group whose members are in different locations. It explains that a GDSS is an interactive computer-based system that supports the process of finding solutions by a group of decision makers. It also defines a decision room as a face-to-face setting for a GDSS, where terminals are available to the participants. This section introduces the Organizational Decision Support System, ODSS, as a computer-based system designed to support decision-making at the organizational level. It highlights key characteristics, involves multiple units, crosses functions and hierarchies, and uses advanced technology. The purpose of ODSS is to improve strategic decisions that affect the whole organization, coordinate activities and decision-makers across different units, and speed up communication and data analysis. This section explains the Executive Support System, ESS, as a broader system that includes not just data, like EIS, but also tools, models, and communication capabilities that help executives analyze, plan, and solve complex problems. It lists main features such as combining data, models, and communication tools, integrating EIS, DSS, and AI tools, supporting collaborative decision-making, and allowing scenario building, forecasting, and simulations. The purpose is to support executive judgment and strategic decision-making beyond just monitoring performance. This section introduces Intelligent Support Systems, ISS, as computer-based tools that apply artificial intelligence, AI, techniques to assist in decision-making, problem-solving, and learning tasks within organizations. It highlights key features such as incorporating AI, machine learning, and expert systems, providing adaptive, interactive, and user-centric support, handling unstructured or semi-structured problems, and learning and improving based on past interactions and data. Benefits include enhancing decision-making under uncertainty and offering recommendations like a human expert. Examples include Intelligent Decision Support Systems, IDSS, expert systems, AI-driven customer service bots, and fraud detection systems. This section defines expert systems, ES, as decision-making software designed to mimic the reasoning ability